addition and subtraction of vectors. Now, before I proceed, I would like to, explain to us what vector and scalar quantities are. Scalar quantities are those quantities that have only magnitude, no direction. Example, we have length, we have work, we have power, distance, we have speed, we have temperature, etc. Then while vector quantities are those quantities that they have both magnitude and direction. What I mean by magnitude here is size. Vectors are those quantities that have both magnitude and direction. Example, we have force, we have acceleration, we have velocity, we have displacement, and so on. So these are what we call vector quantities. And let me explain again. If I want to write this, if I write this A means scalar. But if I put arrow point, it means vector. This arrowhead shows that it has a direction. It is a vector, but this is a scalar. But this is not. So what am I trying to imply, or what am I trying to explain? Vectors are represented using arrowhead. For you to subtract or add vectors, two or more vectors can be added or subtracted if their line segments are placed end to end. If their line segments are placed end to end, I will explain that. The sum of the two or more vectors is called the resultant. The value you obtain after adding it is what we call resultant. And it is represented by the line segment from the initial point of the first vector to the final point of the last vector. Now let me explain. Line segment like this. This is, let me call here A. Then another line segment here, B. This is B. Look at this. Two of them are joined end to end. So then this, from here to here is called the resultant. That is the addition. Here will be A plus B. This is A plus B. So I can decide to call here. Let me say if here is OPQ. I can now say that OQ is equal to OP plus PQ. This is what we call the addition of vectors. And this, we can call this triangle law of vector addition. So we call this, so we can obtain this by saying OP plus what? PQ. What am I trying to say? If we have a OQ, how many ways can we move to what? OQ. We can move it by moving direct from here to here. Or we can decide to move it like this, to get to this point. So this is the resultant of these two vectors. So this now represents addition of what now? Vectors. Now let me show you now subtraction of vectors. I have a straight line like this. And let this line be the midpoint. This line now be the midpoint of this line. Here now is pointing this way. So since we have the midpoint, let this be. If we call here V, then let's call here now U. Then if we call here V, then we will call here minus V. Reason, both of them have the same magnitude but in opposite direction. So if from here to here is equal to from here to here, then here the arrow pointing down represent positive, this will represent negative. So if I complete this now, let me call here O, let me call here P, let me call here now Q. If here is U, here is V, then this, my OP is equals to what now? O, okay, let me call here R. My OP now is equal to OR plus what now? RP. That's addition. Q plus V. Then if I say OQ, OQ equals to now, what will OQ be? It will be now equals to, how can we go here? We can go to here too by moving from here to here, here. So we now have it as what? OR plus what? RQ. OQ now be, let me represent OR. This is OR with what? U. Then, which is this? Then my R will be what? Minus V. So this is the subtraction, and this is the addition. Addition of two vectors. We're talking about two. In my subsequent, how to add several vectors. Here we are talking about only but two vectors. So this is what we call addition of vector. So watch out for example under this.